Okay. Now, shall we proceed? So, related to the dimension, I said the dimension of mass is what? M. The dimension of length is what? L. The dimension of time is what? T. So, as far as this is concerned, if you are to solve any problem related to given physical quantities, here we go. If you are given area under the dimension, it is L, that is length times length, and that will give you L raised to power 2. That is why the unit of area is meter square or centimeter square and so on. Am I right?
Yes, sir.
If you are given volume to solve, that is length times length times length, which is L raised to power 3. And that is why the unit of volume is meter cube. If you are given something like this, speed, to find the dimension will be distance over time. So for distance, which is measured in length, over time, which is measured in t. If this one cross, it will give you length per t. Am I right?
Yes.
That is why the unit is meter per seconds.
You can write it M/S.
Exactly. If you have velocity, which is displacement over time, and because it has distance in it, we have L over t, which is L per t, also given in meter per seconds. This one are the units, the SI units, while this one are the what? The dimension. So that's why they call it equivalent units. Are you getting my point? Now, if you are given acceleration is change in velocity over time. So change in velocity over time, that will give you our velocity already in this place is what? L per t. And time in this place is t. So if you now bring this one here, you are going to have L per t squared. Abi? That is why the unit of acceleration is meter per seconds squared. Hope you understand this. Good. So the next one there is, let us choose density. Make sure you are writing it down. Density. Density, look at the board. Density is mass over volume. So the density, which is mass over volume, mass has the dimension of m, am I right?
Yes.
While the volume have the dimension of what? L raised to power 3. When this one cross up, it will become ml raised to power what? Minus 3. That is m per L cube. That is why the unit of this one is kilogram meter cube, or it may be centimeter cube, depending on what you are calculating. If you make use of, there is what we call metric system. Look at the board. Metric system. Under the metric system, we have what we call CGS, which represents centimeter, followed by gram, followed by seconds. That is what it means. Centimeter, gram, seconds. Are we together there? So as far as this is concerned, now, if you are using CGS metric system, in this place, your mass will be gram. Are you with me now? While your volume will be cm cube. Are you getting my point now? So if you are using if you are using meter, kilogram, s, this one represents meter, this one represents kilogram, while this one represents seconds. Hope you understand the point now. That is another metric system. So if you are using this one now, then you have what you call kilogram meter cube. Can you see that one? These are the metric system. Can I continue?
Yes, sir.
Okay. If you're asked to look for the dimension, let's say you're asked to look for the dimension of force. Are you with me?
Yes, sir.
Look at the board. Force is mass times acceleration.
Due to gravity.
Depends. If you are dealing with acceleration due to gravity or you are dealing with motion on a straight line. If it is due to gravity, the same unit. If it is motion on a straight line, the same unit. Mass, the dimension of mass is m. The dimension of acceleration is L power what? Per t squared. Am I right?
Yes.
Now, combine the two together. You have ml per t squared. That is the dimension. If you are given pressure to work on, pressure has what we call surface area, which is force rather over surface area. So force, which is already in this place, you have what? Mass times what? Acceleration over what?
L square.
Over
Area.
area. So definitely everything here is what you have here, Abi.
Yes.
That is ml per t square over our area,
L2.
which is L square. This one will now cross up and you are going to have ml plus 1. This one will now be plus 1 minus 2 because this one is going up to give us what? T minus 2. Am I right?
Yes, sir.
Eventually you have m. So plus 1 minus 2 will give you what?
Minus 1.
Minus 1 per t squared. That is the dimension of pressure. Are you coping?
Yes, sir.
Good. If you are given work done is force times distance. As far as force is concerned,
We have MLT.
we have it as this one represents the force. So dimension of force now, dimension of force, which is what? ml per t square multiplied by dimension of what? Dimension of distance,
And then L.
and which is what?
L.
L. So combine the two together, we have
M.
ml per t square times what? Times L. That means ml square, then followed by what? T square
Yes.
per t square. Right?
Yes.
Good. Apart from that,
L square MT minus power 1.
apart from that, you can also calculate the dimension of momentum. Look at the board. Dimension of momentum will be, first of all, the momentum itself is mass times velocity. Am I right?
Yes, sir.
So dimension
Of mass is
of mass, which is what?
M.
M, times
Velocity.
dimension of what?
LT. L
Velocity.
per T square.
Which is
L
what?
per T square.
L per t squared. If you now bring the two together, you are going to have m times L per t squared, and that will give you ml per t squared. That is the dimension of momentum. Understand? Okay. There is this particular one again I want us to solve. Now, let's talk about the dimension of surface tension. The dimension of surface tension will be, first of all, surface tension is force over length. So definitely you are going to look for dimension of force, then over what? Dimension of length. So the dimension of force, remember earlier, force is what? That is ml per 3 square. Am I right? Am I right?
Yes, I'm right.
Why this one is what? L in this place. So this one we are going to have ml plus 1 minus 1 followed by 3 raised to the power what? Minus 2. That will now give you m. The l plus 1 minus 1 will give you what? 0. So you are going to have, that is c raised to the power what? Minus 2. That is the dimension. That is the dimension
Surface tension.
of surface tension.
Assuming that